A radio antenna is attached to the top of the building. From a point 12.5 meters from the base of the building on level ground, the angle of elevation of the bottom of the antenna is 47.2 degrees and the angle of elevation of the top is 51.8 degrees. Find the height of the antenna. So the first thing, we need to draw a picture. So first we're going to draw a base of 12.5 meters, so definitely there's a triangle involved. So 12.5 meters, okay, and the building height, let it be like this. And now what we want is the antenna height on the top of that building. We'll label it with a brown color like this, or rather maybe red is better. Like that. Okay, so that's going to be the height of the antenna. So we're told that the angle of elevation to the bottom of that antenna is 47.2. Okay, so the bottom of the antenna is there. So this angle is 47.2, and also 51.8, the angle of elevation to the top of that antenna, right? So if we make this angle to the top, right, that would be 51 in total, right, the larger triangle angle here. So we need to solve for the height of the antenna somehow. Okay, so let's label everything we know. So this is going to be 12.5 meters. This is going to be 47.2 degrees. Okay, and this angle measure is going to be the difference between the 51.8 and 47.2. Okay, so what I'm going to model this with a separate graph, and I'm going to make it bigger so that you see it. So here's what's going to happen. We're going to label this and make it look bigger. It's not going to be drawn to scale, but you're going to see what I mean. The height of the antenna is like this. And again, I'm not drawing this to scale, so don't think that this is the best picture or try to measure it with a protractor, etc. Okay, so what I just drew, and let me be consistent in the colors, what I just drew was a model of the top obtuse triangle, right? This is an obtuse triangle, obviously, because this angle is greater than 90 degrees. I just drew it large, so you're going to see we're going to work on that. So we said that this angle measure was the difference between 47.2 and 51.8, right? Because the total angle from the ground level to the top was 51.8. 51.8 minus 47.2 is going to be 4.6, right? So this must be 4.6 degrees. This small one, right? I can label it here so you can see 4.6 degrees. I could barely fit it there, right? 4.6. And this is the height of the antenna that we need to solve for, right? And now the thing is, we need to find this angle, right? The alpha angle, because we're going to need that together with this hypotenuse. How do we label this hypotenuse of this triangle? We can label it as B, right? Because the angle elevation to the bottom, it says angle elevation of the bottom of the antenna, right? So we can label this hypotenuse as the B, because we know it follows from the angle, this hypotenuse is drawn from the angle of elevation to the bottom of the antenna, right? So let's label it B. So if we solve for B and we solve for alpha, we can use that information to solve for H using the law of sines, So how do we find? First of all, notice that this is a right triangle because the ground level, the buildings are always built so that they're perpendicular to the ground, right? Always built perpendicular. Otherwise, the buildings would fall, right? They're always perpendicular. So this is a right triangle. So that means this is 90 degrees, and we can find the alpha, right? Because the alpha right? And I can label it here. This is the alpha. We can find the alpha because the alpha is going to be the difference between the 90 degrees and this total angle, which was 51.8, right? The 4.6 and 47.2 together. Okay, so we can find the alpha that way. So we know that the alpha is equal to 180 minus 90 minus 51.8, right? We know that. And the calculator, let's see what that gives us. That's 90 minus 51.8, 38.2 degrees. Okay, so we got that value. So we can already correct that, and we can edit that and write 38.2 degrees. Okay. Now let's solve for the b though. The b is solvable by actually, we cannot use Pythagorean theorem unless we find this height here of the height of the building, right? This is the height of the building. We can't, it's going to take too long, right? So why don't we use actually arc cosine? No, not arc cosine, but cosine function, right? We already know the angle measure. So we're going to use the cosine for the adjacent and the hypotenuse, right? Because this is the angle whose adjacent side is 12.5 and whose hypotenuse is the b that we don't know. So what I'm saying is to find the b, we're going to set cosine of 47.2 degrees is equal to the adjacent side of this triangle over the b, the hypotenuse, right? That way we can find the b, and then everything will be great to use the law of sines, right? So let's see. That means to solve for b, you will need to multiply both sides by b and then divide by cosine of 47.2 both sides, right, to solve for b. So that means essentially b is equal to 12.5 divided by the cosine of 47.2, right? This is the algebraic manipulation. So as a result, b is equal to what? Let's see what the calculator gives. 12.5 divided by 47.2, taking the cosine of that, gives me 18.39, and I'm just going to copy the whole number down. 7468, 746851 meters, right? So that's the value. So we can copy that down, erase this b, and copy that down because now we got it. So this is 18.39, 746851, right? So now, as you can see, we have everything to use the law of sines. Recall the law of sines relates in proportion the angle and the opposite sides, right, being equal in two fractions. So what I mean is it's listed as sine of 4.6 over its respective opposite side, which is the h in this case, is equal to sine of 38.2 that we just found, the angle measure before, divided by its respective opposite side of that angle, which is 18 point, also the one that we just found, right? 746851, right? So this would require cross multiplication. So as a result, what I'm saying is these two would be multiplied and these two would be multiplied, right? So essentially, when you do this correctly, you should get h is equal to the product of these two. So 18.3974681 times the sine of 4.6 being divided by sine of 38.2. That solves for the h. So if you do this in your calculator and being sure that you're in the radian mode, degree mode, so I get sine times 18.39, 74685. 1 and divide by 38.2, we're taking the sine of that. I'm getting 2.385894 493. So we have to round that, right? We have to round that answer because the number of significant figures was 3 here, right? As you can see, there are 3 digits here: 4, 7, 1, 2, 3, 1, 2, 3, 1, 2, 3, right? So we have to have 3 digits here. So that means we round to the nearest hundredth because we have 1, 2, and 3, right? To the nearest hundredth. Since this is a 5, this is the nearest, this is the hundredth. Since there's a 5, 5 pushes the 8 into a 9, right? So this becomes about 2.39 meters. So this answers this question for this word problem. So thanks so much for watching. I hope you found it helpful in understanding the law of sines and how to get to the desired unknown sides and angles. And I'll see you in the next video. Thank you.